Right. Welcome everyone to the February cluster call for Data Readiness Cluster. And today we have a guest speaker from Google. So Omar is a software engineer at Google, where he has developed data-focused products like the Google Public Data Explorer, data search, Google Data Set Search, and search features like media reviews, public statistic answers, and related entities for over a decade and a half. And before joining Google, Omar received a PhD in database from, I'm not sure how I pronounce it, but INRIA, which University of Paris, Orsay, and spent 2 years as a postdoc in the database group at Stanford University. And today we have Omar presenting about a really exciting development from the ML Commons side for the Croissant. And I will turn the mic to Omar. The floor is yours.
Thanks, Douglas. Can you all see my screen?
Yes, we can.
Okay, great. All right, so I'm very happy to talk to you about Croissant today. So this is an effort that started a little bit less than a year ago with some folks at Google, and then quickly with folks with ML Commons and a bunch of other groups. And we are pretty excited because we are about to do our official launch next week. So you're getting a primer of what will be. Everything is available publicly, but just communicated a bit more on next week. So the goal of Croissant is to help machine learning users with datasets, right? And so what we notice is that there's a lot of difficulties that users encounter when they work with datasets in machine learning. And lots of machine learning datasets are often structured in strange ways, and which requires users to spend a lot of efforts on these data-related tasks. And so we wonder, okay, what's special about machine learning datasets compared to open data from governments or public statistics and so on. So these are some of the characteristics we noticed, is that data can be either structured or unstructured, or sometimes both. Very often you need to flatten your data into records so that it's easier to load the data into the machine learning frameworks. And you also need some machine learning specific metadata, like responsible AI information, what's the test train, validation splits, labels, and so on. And also version management is important because reproducibility is important. So we need to make sure that it can be represented for datasets. So what we set out to do is to say, okay, let's create a metadata format for machine learning datasets that captures all the useful information that is needed about datasets so that it's easier for users to work with these datasets. And so we defined a format that has these 4 layers. The first layer is just general dataset level metadata, and then a layer to describe resources properly, like files, folders, archives, and so on. A layer for the content structure, and I'll give some examples of all those in a minute, and then some information about the machine learning semantics of the datasets. And we think the benefits of having such a format is one that you can have a homogeneous large-scale corpus of all of machine learning datasets across vendors, platforms, and so on. Right? So this should make it easier for users to find, discover, and use those datasets, and using tools like dataset search or by going to repositories directly and so on. And secondly, if all datasets use the common format, then we get better interoperability between the tools. So it doesn't matter if you get your dataset from Hugging Face, you can still use it on Kaggle or use your favorite machine learning framework independently of where the data came from. And then an ecosystem of other tools can start supporting this format and come to improve even more the experience of the ML users by having functionality around like data analysis or visualization or labeling and so on. And eventually users should spend less time on data munging and more time on understanding their data and building useful functionality and models and so on. We decided to build this on top of schema.org, which is already today the most commonly used format to describe dataset metadata on the web, and is really web friendly and easy to index and surface by search engines. And so we decided to extend schema.org/dataset, which is a vocabulary that exists today for datasets, and add some functionality that was missing to it. The first simple one is, describing resources properly. It's schema.org does not have a very good way of describing all the files and directories and so on that are in your data set. So that's the first extension. And then we added some aspects that were more specific to the machine learning use case, like, I'll describe those in a second. And the way we did that is by creating a new namespace, so mlcommons.org/croissant, and Croissant descriptions are essentially a mix of properties that come from the Croissant namespace and properties that come from the schema.org namespace. And this is an approach that's similar to what the bioschemas community did for defining extensions to schema.org as well, if you're familiar with that. I also wanted to say, if you have any questions, please don't hesitate to interrupt me at any point in time. It will make it more interactive and less boring than listening to a talk for the whole time. The other aspect that was important to us is responsible AI, and so there's a subgroup within the Croissant community that is looking at responsible AI aspects and is creating a first promoting Croissant as a tool for responsible AI, because having better description of datasets already helps with the responsible AI aspects of the data, but also defining a core responsible AI vocabulary, which is an extension of the Croissant vocabulary that is organized around the use cases that are listed here. And so this is work that is happening right now, and together with the 1.0 specification of Croissant, we'll be also releasing the core responsible AI vocabulary. And also what I want to say is this is actually a pretty good model of how you can have extensions that are developed next to or in parallel with the Croissant format. And I believe Rajat at the end of this talk will tell us a bit about the work he's been doing on a potential geospatial extension for Croissant. All right, I'll jump to a demo just to show you kind of how things fit together in the Croissant space. So we'll start with what happens if you're a dataset consumer, right? So you're a dataset consumer here. You want to find some datasets, and so you might go to dataset search or just go anywhere on the web, or go straight to your favorite repository, and then you'll find some Croissant datasets, hopefully, and you'll be able to download those and then load them into your favorite notebook environment using your library that will let you create training examples or the such from your data. And so this is the journey that we want to enable with Croissant. All right, so I'm going to switch to a different tab. So let's say I search for something like object detection, dataset. You can see I've done this search before. So this is actually not a feature of Croissant, but a feature of the dataset search, which has this integration with Google Search that shows this dataset section with some datasets. So you can either go straight to one of these datasets. None of those will be, or maybe this one will be a Croissant dataset. Or you can click on more datasets, which takes you to the dataset search page. On the dataset search page, you have a Croissant filter, that you can click, select. I don't know if you can see the tooltip, but it has some documentation just for users who have no idea what Croissant is. And now I will see only Croissant datasets. It's still the beginning, so the metadata is not really complete. But let's say, for instance, I found this useful Hugging Face dataset. If I know that it's in the Croissant format, and I can go to Hugging Face page for this dataset. Now I'm switching over to that page, and here, if my demo effect, well, within the tags of this dataset, there is a Croissant tag here. So if you click the Croissant tag, you can again get some information about Croissant, and you can download all the Croissant metadata straight from the Hugging Face website. You can also list all the datasets that have Croissant metadata on Hugging Face. And so you can see that there are 73,800 Croissant datasets on Hugging Face. And this is because the Croissant metadata is generated automatically by Hugging Face from the metadata they already have in their system, right? And this is the case for Kaggle, for Hugging Face. It's also the case for Kaggle and OpenML. So if I go back to my dataset search result page, let's pick a Kaggle dataset now. If I click on the Kaggle link, so now I can go to this corresponding page on Kaggle. And here, next to the download button, there is in the dropdown, there is export metadata as Croissant. And again, this will give us a download of
Omar,
Yep.
We're still seeing the Google dataset search page, not the Kaggle page.
I'm sorry, could you say that again?
We're still seeing the Google dataset search page, not the Kaggle page if you opened one.
Oh, thank you. Yeah, sorry. It didn't switch the tab automatically. So this is the Kaggle page for the dataset. And in the download drop down here, you have export metadata as Croissant, which again gives you a JSON-LD for representation of the Croissant dataset. So now that you have your Croissant dataset in hand, what might you do with it? So just to show you an example, this is a Colab, so a Google notebook that was created to show how you can work with Croissant datasets. So this one, I will just scroll just to show you quickly what this looks like. But essentially, I showed you how Hugging Face gives download access to Croissant datasets. You can also give the Croissant data from the Hugging Face API. So here we are downloading the Croissant dataset, which looks like this. We'll look at the details of the Croissant later. But just to give you what I wanted to show you is there is in TensorFlow datasets, which is a library built by Google that lets you use different loaders for creating a machine learning, preparing machine learning dataset for training. There's a simple builder that just takes the Croissant file and builds it for you so that you can use it for loading. So in this example, the dataset is built, and then it's used to train fashion MNIST model. All right, the model training is here. And this one actually uses PyTorch. In TFDS, you can use either TensorFlow or JAX or PyTorch because it has many data loaders. All right, so going back to the slide, this is essentially what we saw. Is like we went through these steps all the way to like training a model without having to do any kind of data munging or preparation to work with the data. There's also a Python library that can be used to work with the dataset and validate or consume the records of the dataset. Oops, sorry. Okay, so this was from the point of view of a dataset consumer. Now, suppose you're a dataset creator. Okay, so you want you have some data and you want to publish your data in Croissant format. And how might you do that, right? So you have some data files. Really, there are two paths available to you in Croissant. You can the easy path is maybe I shouldn't say that, is if you're using a repository that already supports the Croissant format, like Hugging Face or Kaggle or OpenML, which I did not show in the demo, but it also supports Croissant. Then all you have to do is upload your data set to that platform, fill out whatever metadata you need to fill out in that platform, and then they will generate the Croissant metadata for you. Alternatively, you can use our Croissant editor, which is a UI tool that we built for creating Croissant. And the Croissant editor will let you also start from your data files, define your metadata. It will try to infer as much as possible the structure of your data set, and then it will output a valid Croissant representation of your data set, Croissant metadata, and then you can put that on your website so that it's discoverable by search engines and so on. All right, so I will just show quickly the Croissant editor. I have a video here, but I'll try to do a live demo instead. So this is a all right. It says running. Oh, there we go. All right. So this is a Streamlit app that is also open source. You can download it from our GitHub repository. There's also a version hosted on Hugging Face Spaces because they support hosting Streamlit apps. So this is a Croissant editor. You can do a number of things. You can create a data set from scratch. I will not demo that because I don't have some data files to work with right now. But basically you upload some data and then it will try to guess the metadata for you. Instead, I will just look at one of the existing data sets. So this is the Cocoa data set. You have some information about, if there are any validation errors or warnings, then you will see them here. And this is the name and description, which you can edit. And then you have general metadata about the data set, including citation, some responsible AI attributes. And there is actually an effort at the moment to create a more extensive responsible AI metadata editor. So that will be a separate tab in this application. And we're trying to come up with a model where extensions, such as like the responsible AI extension or other extensions, can easily create tabs in this editor for editing specific metadata for that aspect or vertical. So this is general metadata. And then the resources, this is where you can upload your files. And so in this case, the data set contains these files, and we can basically go and look at them. So this is a zip file, actually 3 zip files that are concatenated together to generate a set of, and extract a set of image files, and then a bunch of annotations. I won't go into too much detail about the editor, but the main benefit is that you can basically create a full Croissant dataset without understanding JSON-LD, which is probably a relief for many users. So this is the resource side, and then the structured side here is in the record sets. So these are the actual records that exist in the data set, which are here split into these 5 categories. I'll try to click on one of them. So these are the fields. So this one has 4 fields. It's the captions. There should be a preview, but there is no preview for this one. All right, so that's the editor. So if you're creating a data set from scratch, once you're done with editing your data, you click the export button, and once again, you can download the JSON LD. Alternatively, if you found a data set on the web that you liked, and you want to load the JSON LD, you can just upload the JSON LD here, and then you will see all the metadata and edit it in the editor if you like. All right, so going back to my slide here, this is the journey that we just looked at, which basically tries to make it as easy as possible for dataset publishers to turn their datasets into Croissant datasets. All right, I will pause and just see if there are any questions so far.
I actually do have a question. So how much writing do I have to do for this? Like, will it do the entire metadata, or does it already take, like, do I already have to have it well documented and this is just providing a wrapper around it, or is it actually creating metadata?
This is a way to, so it depends. If your data, if you already have metadata in, say, schema.org/dataset, then you don't have to, the metadata will just be imported because we use the same representation for that metadata. The editor lets you define your own metadata. There are a few fields that are required, like minimal information, like name, description, and license, and so on. So at the minimum, you have to select those fields, and then the rest will be generated for you. Like once you upload your data files, let's say you upload a zip file containing a set of images, then it will understand the structure of those, and put that in the description of the dataset. Or if you have a CSV file, the editor will try to guess the names and types of the columns of the CSV file, and also generate metadata for those.
Great, thanks. And what about NetCDF files? Since those are self-descriptive, is it able to then just grab the metadata from those?
We did not look into understanding files in or dataset descriptions in other formats, but that would certainly be a very good project to invest in, like converters from existing metadata formats into Croissant, and vice versa.
Thanks,
Okay,
Kathy.
great.
I think you're getting to some of the discussion we may want to have after this. So we can have more discussion on that part. Aaron, go ahead. You have your hand raised.
Yeah, thanks. I have a question from the point of view of a data repository. So we're currently using, I work at the National Centers for Environmental Information, and we're using schema.org already, kind of in its vanilla form, to publish data sets. And I'm just wondering if there's any tutorials out there that would kind of help build out the capability to publish Croissant, the additional extensions that you have for Croissant, once we have data sets that are in that format. And then with regard to the Croissant editor, is that metadata something you can download and then host the data? Is the expectation the data repository would host that? And also, did I understand correctly that data is uploaded to Croissant editor? Or is there some limitation on file sizes that I might have missed that?
All right. So to answer your first question, if you already have datasets in schema.org/dataset, then yeah, the Croissant work is purely incremental. It's just a few additional attributes that you can add. And there is, so if you go to mlcommons.org/Croissant, which right now redirects to our GitHub repository, there should be a link to the spec, the Croissant spec, which essentially documents all the fields and all the information that you can add in Croissant. And we also have a bunch of example data sets in our GitHub repository. So those are also useful resource to look at and we can also probably create additional documentation to make it even easier to understand how to support Croissant. Now, for your second question, which was about uploading to the editor. So the editor is it's also on our GitHub repository. You can download it onto your computer and run it locally, and then you're uploading to the editor, but it's on your own machine. So there shouldn't be. I mean, there's probably issues if you try it on very large data sets. We have done a bit of experimentation, and we did run into some issues with large data sets. So it's not really optimized for handling very large data. And it's also focused on the metadata definition. What does large mean? Yeah, that's a good question. I think tens of megabytes is probably fine, and larger than that might cause some issues. But the focus of the editor is really on metadata definition, not so much on process consumption of the or querying or viewing the data. Yeah, I know that's and actually we should probably there's probably some interesting work to do on like how to adapt Croissant and the tools in the context of geoscience datasets.
Thank you.
Thanks, Omar. And Reina?
This might make more sense in the discussion, so just tell me if that's the case.
Maybe let's go through.
Yeah,
I was just thinking maybe go through the formats overview, and then I know we have a lot of people interested in how geoscience fit into this like Croissant formats.
Yeah, okay, so I'll wait for that. Okay.
Right. Thanks. Go ahead, Omar, maybe finish the overview and then we can go to the discussion.
All right, sounds good. And I'll go quickly over the overview because so that we have more time for discussion. So this is just a quick overview of the contents of a Croissant dataset. The first part, and this is in JSON-LD, so it's one of the most common representations for schema.org data. So the top level is really just general metadata about the dataset, and this is, you might recognize the schema.org/dataset vocabulary. It's just standard schema.org description. The only field here that I added is so CR is just a prefix for Croissant. So cite as is basically the citation information for the dataset. Schema.org has a citation field, but unfortunately that means citations from this dataset of other works, not information about how this work should be cited. So that's the first part. The second part is information about the resources contained in the dataset. And so the resources are of two kinds. The first one is file objects. So these are just an enumeration of file objects. And then the second one is what we call the file set, which is a set of files that are homogeneous and often are extracted from some other file object. So the combination of file object and file set we found is sufficient to describe most of the layouts of data sets that we tried to work with. And so in this example, for instance, there is a metadata file, which is a CSV file, and then there is a archive which contains images. In fact, PAS contains 9 archive files named PAS0 through PAS9.tar, and then the overall set of images is obtained by extracting from the union of all the zip or the tar files, extracting all the JPEG images. So just to illustrate how resources are described in the Croissant format. And then the next layer is really the structure of the data. So this is where we describe how the data is organized, and this, what Croissant tries to do is to provide a single way to describe resources, whether they're structured or unstructured. So in this example, we have structured data like CSV files, And for instance, this is from the movie lens dataset, which is a movie recommendation dataset. So in movie lens, so this record set, which is the structure that we define, contains fields which are the equivalent, correspond to columns here, but you could also have nested fields to capture things like JSON annotations and so on. So the movies record set contains a movie ID and a title, a genre, and each of those is extracted from a CSV file, which is the movies table that we saw earlier, and they correspond to different columns, right? So movie ID and title, and here the genres column, you have an example of the CSV file at the bottom right here. And you can see that the genres column actually is a list of values that are separated by the pipe character. And so we have a functionality in Croissant that allows you to do some simple transformations on data values. In this case, we extract these values into an array by applying by using the separator, which is the pipe character. So this is what a description of a structured CSV file looks like. In the next example, we have a combination of structured and unstructured files. Going back to, I think, again, this is the past data set. So we're creating a record set which will contain every image in the data set. And for each image, we're going to add additional fields that are extracted from the metadata.csv file. So those are additional features of the image, if you like. So the way this is done is, well, we start with the image content, which is extracted from the file set, which is the set of all the JPEG files that we defined earlier. And we extract basically the content of each image. And then this is actually how it's done in PASS, right? Every image file is actually a hash of the file with .jpeg with the extension afterwards. So we need to go and extract the hash of the image from the file name, which is done this way. So we start from the file set image files, and we get the property file name, and then we transform it using this regular expression that extracts the hash. And then this allows us to join with the CSV file, which is what this references field does here. So we join with the CSV file on the hash. So the CSV file has a column that's called image hash, which contains the hash. And once we have the join, then we can pull additional metadata from fields from the metadata CSV file, right? So we can get the creator name and GPS coordinates. And here, this is an example of how you can actually have nested fields. So the GPS coordinates field uses the schema.org geocoordinates type, and we can extract latitude and longitude from the columns latitude and longitude of the CSV file. All right, I'll stop here for the description of the metadata. There's more details to it. I'm happy to answer any questions you have on these, on the actual format. But there's a lot more details in the specification that's linked, and the examples that are on the GitHub site. But hopefully this gives you a little flavor of what the Croissant format looks like. All right, I'm getting to the end. So I just wanted to say what's next. So the official launch, which is hopefully next week, which these are all the things that will be part of this launch, and I showed you a lot of those in the demo. There's an active community that meets. We have meetings every week, and we have folks from lots of organizations, including NASA and Meta and Hugging Face, and also people from academia. And some efforts on developing the core Croissant format, and also some efforts around extensions to the Croissant format. I mentioned the responsible AI extension, but also some work that has started on geospatial extension, and some early interest in like Croissant for life sciences and so on. So I invite you to join us if you're interested.
Thanks, Omar. This is really helpful, and I'm really excited to see that launch next week, hopefully. And yes, Arena, go ahead with your question.
Okay, yeah, more discussion / question. Yeah, I'm trying to think about like the reality of this from a repository point of view, and I'm coming across like some things in my mind that I'm not sure how they fit in. Like, so one thing is this idea of like dynamic data sets versus sort of these static data sets maybe used for training or testing. So like where you have time series data and maybe, I don't know, I'm just trying to imagine like how a repository would do this. Like they have their, let's say they have their regular time series of temperature, and then maybe they've extracted some labeled data of particular temperature events and maybe put like parceled that off as like a special potential training or testing data set for temperature events. And that's basically another data set, but derived from the original time series. That over time, though, they might get more training events that they've labeled, either that they've gone through in their back history or as new events happen. And so they can version that training data set to have more examples. But I'm just, yeah, I'm not really sure how the versioning or the dynamic element comes in. And I'm also confused by if there's been some like processing from sort of a more raw data set to get in the form that's amenable to the AI or machine learning algorithms. You've trained on this sort of other format, but the raw data to continuously feed it after the fact is different. How do we kind of reconcile that? Do you see what I'm saying?
Yeah. All right, so I'm hearing two different aspects. One which is
multiple things going on. Sorry.
Yeah. And I don't think I have answers to all those, but some elements like so the first aspect is live data versus snapshots or versions of data, and this is a need that we did identify in like a lot of like machine learning cases, and so we have two things. One is recommendations on how to specify versions of data sets, and for that there's like a version field. So this is for the case where you have a static or like a specific release of data, you should specify a version there, and we recommend like some semantic versioning as a naming scheme, but that's not like, if people want to use something else they can use something else. And then for data sets that are continuously updating, we added a field to say this is a live data set. So you can say this is live data set, and so know like every time you download this data set at this URL, you might get newer, fresher data. Like it's not going to be a static data set. So I think that's the first aspect. The other aspect is what happens when you process the data or when you have some data set that is derived from some other raw data via some processing, and this is to me a really important aspect of data provenance and lineage, and sort of keeping track of the transformations, and also knowing what was the original version of the data that was processed, so that the derived data, like if there's new source data, you can reason about the derived data if it's still useful or not. This is not something that is described in Croissant currently, but several people in the working group have expressed interest on working on that and figuring out what's the right good way to represent that, or if there's an existing vocabulary that already captures that, how we can incorporate that and make it work with Croissant.
Thanks, Omar. For the context, maybe we should let Rajat give a quick presentation of a proposal of adding some geospatial extension to it and to the Croissant. And I think this is some discussion has been happening. Seth, I will let you ask your question after I let Rajat to do a quick presentation. Rajat, go ahead, share your screen if you want.
Sure. Thank you so much. And I'm happy to see the discussion going around, so it would be a good time. And thank you, Omar, for the great presentation. I hope you all are able to see my screen.
Yes, I hear.
Perfect. Yeah, so this was the original presentation which we gave to the main Croissant core working group, and it was given by Dr. Manil Maski. He's also on the call, so please feel free to add anything, Manil. And I'll keep it short. And so we all know about the operating and future science fleet, petabytes of information coming in, new satellites being launched, new information being coming in, and then it creates a gap between how these information can be transformed to a AI-ready datasets. And with the Croissant, when we were looking into it, so we got very excited of seeing what are the opportunities which we can look into geospatial datasets and how those can be incorporated, because we have Google Earth Engine is there, NASA, NOAA, all of the big organizations have their own datasets, and they have been actively working on AI-ready datasets format. So Croissant, it kind of gives a good platform to directly use it as a data loader and also generate a workflow in an end-to-end fashion. So giving one example for the geospatial foundation model, the Prithvi, which we developed in collaboration with IBM, and it has a lot of aspects with respect to training data. So there is a pre-training data set which is used for foundation model, and then there are also the downstream application data set. So for example, the model can be used for classifying crops or detecting burn scars. So all of these different tasks have their own data sets, and they can be directly represented in form of Croissant format for efficient representation. Uh, when we talk about geospatial datasets, and I guess a lot of us are already aware of it, so the complexity comes from what are the spectral dimensions, what are the temporal dependencies, spatial dependencies. Then, as we talked about, like Katie also mentioned that the data volume is too big to handle, and how we can use it. So then there are sampling biases, then there are privacy and ethical concerns. There are information like from where the data is coming. There are temporal information associated with it. So all these complexities with geospatial datasets makes a way of how we can expand the Croissant core specification and incorporate new modifications to it. Of course, we know about types of geospatial datasets, and there are constant developments going in the form of stack or training data markup language. But then these standards are not directly interoperable with the existing other computer vision based dataset formats. So since there is a wide attention coming for the Croissant working group with respect to Hugging Face and Kaggle, then it makes a very good chance for us to talk about these. And when we talk about these, so the unique characteristics of a geospatial dataset with respect to AI-ready datasets. So these unique characteristics are already defined in schema.org with some of the attributes, and some of them are not there. So the use case which we will be working on for the geospatial datasets would incorporate to define those extensions and how we can incorporate the Croissant core specification with these attributes. So attributes like spatial coverage or temporal coverage, projection is a very good example of this, because projection is really very important when we're talking about geospatial AI-ready datasets from a metadata perspective. Then we also do 3D or DEM-based analysis where elevation is important. So then the vertical resolution comes into picture, which is usually not defined in a basic computer vision approach, but is very useful for AI-ready applications involving Earth observation data. So with this, I will quickly show one example for the burn scars fine-tuning dataset. This is available on Hugging Face, and we worked with. I'm sure you are able to see the slides, right? Currently, I'm on a example slide.
It's very small, so I cannot see the details in it.
Oh,
yeah,
how about now?
better now. Yeah.
Okay, thank you, Douglas. And yeah, so this is the example. Omar has already shown it for the core specification. For the geospatial dataset, which is already there, it kinds of look like this, but it still misses some of the properties So if we'll see the file object and file set, so we were looking at the Croissant format overview, and these are the way how it is defined. So all the entire gzip file is stored in the file object, and then we have file set, which defines the TIFF images. We also have file set for the annotations. But then about the REI extension, so this is also coming up, like from where the data is collected, information about the data collection type, citation info. So these are all the responsible AI attributes. There are even more responsible AI attributes like geospatial biases or sampling, specifically for the agricultural data sets. Like sampling and the time of the data set plays a lot of significance. So these all information are coming up in as a part of the RAI extension. But we have been thinking about and doing a lot of discussion with some of the folks who are already present here to propose a GeoCroissant extension. And this is kind of like one more extension to Croissant Core and RAI for efficiently representation of geospatial metadata and RAI attributes. If we talk about the examples which we saw recently, like the spatial reference information is missing, nested data attributes. Katie mentioned about NetCDF4, and then there have been interest about the cloud native geospatial formats, so ZAR files, and how we can incorporate the converters or how we can update the converters to incorporate these data formats would be essential to bring up the entire geospatial or geoscience data community in this effort. And then one more important thing is the region restricted data access. So a lot of NASA data or NOAA data is being stored in the DAX. And whenever a person is working on an AI ready data set or working on an AI algorithm, they do not need to download a particular chunk of data set based on resource constraint and then train the model. They can directly use a Croissant file, which is having a geospatial extension to defining the metadata related to geospatial problems, and then they can pass it on to the data loaders. Also opens up the opportunities for data fusion with other approaches, like tabular data can be fused. So recently we were working on the problems involving census data. So those are the tabular data. So how we can incorporate those with raster or vector-based data sets. So we envision using GeoCroissant as a community standard for ML, EO, AI-ready datasets. And this could be a good universal format so that everybody can work on it, and there is an interoperability which can work across the entire scientific problems. And at this point, I think it would be good to call for GeoCroissant working group. So Omar, Manil, and the entire ML Commons group, Douglas, we have been discussing about this. And if you are interested, so then please join us. Probably this will, not probably, this is for sure will not be possible in the upcoming launch, but we'll be having further iterations. And then if we have a GeoCroissant extension, then we would need all of your help to make it possible and make it viable. So you can reach out to any of us, and yeah, I think that's it. And thank you for the opportunity to present it in a short notice.
Right. Thanks, Rajat. Seth, go ahead.
Yeah, sorry. Just before that, Manil, if you have anything to add, then please feel free to add. And yeah, yes, sir, please go ahead.
Yeah. So I just wanted to flag two things that I think folks working on something like GeoCroissant should keep in mind. One is that, data volume for earth science data is much bigger than a lot of other fields. And so that not only does that mean that, ideas of like, oh, you can't just have your data set and upload it, but also that means that, sometimes things like versioning gets affected. Like I manage a couple data sets that are versioned, but we cannot keep old versions. It's prohibitive resource wise. So, when a data set gets updated, the old version gets thrown out. Sorry. So that's, that'll be something to, things like that will be something to think about. The other thing is that when we're talking about model data, and this is, I think, particularly relevant for the RAI component. So like climate model data looks like observational data, but there's a lot of ways in which it is different, and it's really, really important that it's different. And people who are not experienced with climate data often miss that and get it wrong. Like, you know, the calendars that the models use can be different from real world calendars. So if you just try to read your data in using Xarray, it'll do weird stuff with the time coordinates. You know, and also this is a really big one that I see end users get wrong a lot, and it makes an enormous difference. There is no correspondence at all between the sequence of historical events in a model and the sequence of historical events in reality. Like, you should not expect that the weather on a particular day in reality and the weather on a particular day in a climate simulation have anything to do with each other. So, you know, with regard to all of the you know, information about this data set and stuff, you might want to think about ways that you can, like, set off sirens and wave giant red flags saying, hey, be aware of these things, because I think there's the potential for people to do, you know, AI research that gets things wrong in dramatically bad, but also very subtle ways.
Great. Thanks, Seth. Any response from Omar or Rajat?
I have a very uninformed comment to make on what you said.
Yeah, go ahead.
So, I mean, I'm not really familiar with your domain of data sets, but this reminds me a bit of what happens in even just statistical data, right? Like, you get data from census or from BLS and so on, and sometimes things look kind of the same, like they use the same variable name or something, but the methodology is very different. And so combining that data together leads to like huge mistakes. And I think that this is a challenge for AI, because we're training models by just throwing lots of data at them, and this type of considerations around, okay, but is this meaningful? Like, can all this data, like, is there enough context around the data to help that the models can learn the differences and take them into account? I think that is a real challenge for me.
Rajat?
Yeah, I don't think
Yeah.
this is something especially new to this field. I think it's just that, you know, we should like probably somebody in the project should like make a big list of like, here's all the things that we should make sure are well flagged of the differences between this kind of data and other kinds of data that people may be used to working with.
Yeah, I completely agree with both the points, and I have noted both of them. So, because with the weather, the example which you said about climate model data, it's perfectly relevant, because with time the data set changes, and with every application the data set changes. So somebody is working at cloud microphysics, the data would be different. Somebody working at the entire prediction, the data would be different, and the scale would be different as well. So yeah, these are all the points which we can incorporate while defining the geospatial, the GeoCroissant extension. And yeah, thank you for your inputs.
Thanks, Rajat. I'm gonna ask if Doc Fields want to chime in, because I know the SOTA or the science-on-schema.org is something I briefly mentioned to them before, but I think you might be a better person to speak about that.
Well, yeah, and I think Adam Shepard was on earlier too. I don't know if he still is, but no, I mean, this is really exciting. You know, there's work going on in ESIP on leveraging JSON LD type data set, and providing some guidance around that in the SOSO group that I put the link in there. There's also the work that's going on in RO crates. That's also leveraging JSON LD for description of those, you know, fair digital object crates. And so, you know, you can have your different opinions on what that, how that's going. But I think it's really interesting to see Croissant both as a profile, where I have JSON LD schema.org type data set, and also as a data package, and see, you know, where could we have alignment, right? Or maybe, triple SOM mappings between some of these things, or things like that, right? So just really be interesting to start that conversation.
Yeah, I think the mapping component you mentioned, Doc, is really interesting, especially for this existing. It's already out there. How can we like directly map into some things that like Croissant or the GeoCroissant extension might be
Right.
trying to do? So yeah.
And I just mentioned the
All right.
Geosparkle stuff simply because as you're talking about spatial stuff, you know, in some ways it'd be nice to leverage existing vocabularies to the extent possible for some of those spatial elements.
Right. We have 2 minutes left. I think I'm gonna try to ask for one last question. That's quick. Aaron asked a question that could you describe the labeling in the context of Croissant, and maybe how does the Croissant extension handle labeling that may happen in the geospatial like data in this sense?
Yeah, so quickly, at the moment, we just have a way in Croissant to say that some fields in some record sets are annotations of other fields, and we have a mechanism for semantic types, and we're hoping to use that to describe information about labels, so that if you need to say something about, either the person who did the labeling or any additional information about the labeling act, that this is something that could be described as the granularity of individual records in the data, and not just as and of course, as a general metadata level attribute. There is a responsible AI attribute to say general things about labeling of the data set. Rajat, do you want to add something about geospatial data sets?
I just echo your statements. So yeah, the RAI attributes can be taken from the RAI extension. And if anything is required, then we can add those to the additional attributes in Geo. Thank
All right. Thanks. We are unfortunately out of time, so we will keep all the chats. And so if there's any follow-up question, we may be able to follow up. And thanks for putting in the chat right now. And thanks again, Omar and Rajat, for this really interesting presentation and conversations. We'll see how can we push this even further for the geospatial application.
Thank you very much.
Thank you.
Thanks. Bye, everyone.
Bye.
Thanks for facilitating.